Howdy. Welcome, everybody. As Lara said, my name is Devin, and I'm here today to talk to you all about embedded application development. Now, I am a freelancer. I've been a freelancer for a good while, the last 8 years or so, and over those 8 years, most of the work that I've done has been on the web. And last year, I had a call from a client that was potentially interested in working with me, and they said, we have this API, it's using this language called Elixir, which I've been using pretty much exclusively since the middle of 2016. And they said, we want you to help us finish out the MVP of this product, clean up some tech debt, help with, guiding our developers. And I said, that sounds like something I can help you with. I'm totally interested. Let's do it. And then they also said, oh yeah, by the way, we also have this other thing. We have this other Elixir application that's running on some hardware. It's an embedded application. And we have someone working on it, but maybe you can help him with it every now and then if he has questions or something. I said, yeah, totally. I know Elixir. I can do that. I'd be happy to help in whatever way I can. And so I started this project, and about a month into it, that other person kind of disappeared, which happens, I guess. And so it fell to me. And then it became an embedded application for someone who was essentially a web developer. That's mostly what I've been doing. And whenever I talk about embedded applications, one of the first things that people ask me is like, what is an embedded application? What's embedded software? And it's kind of a difficult thing to say because this has a lot of embedded software in it these days. And we know this because every now and then, whenever some natural disaster is bearing down on America, some engineer at Tesla headquarters can push a button and they can say, okay, if your Tesla used to get 200 miles of range, now it gets 250 miles of range. They're doing an over-the-air software update, and the only difference between how much range you have in one versus another car is the software in that car. That means there's a lot of embedded software in there, and that's not the only thing, but that's one thing that they do with software in a Tesla. And now that's also not the only way to tell where there's embedded software. Another way you can tell is if you look in user manuals and instruction booklets for a lot of devices these days, you might see something like this, telling you that there's open source software in whatever thing that you've bought. This specific example comes from a Samsung refrigerator. And if you go to the link that they give you there, you can get a full breakdown of all of the open source software, at least the GPL and the LGPL software that they've put in your refrigerator. And we can see that they're running the Linux kernel on your refrigerator. So in 2019, we're still waiting for the year of Linux on the desktop, but yet the year of Linux on the refrigerator has already arrived. And this is the future. This is the Internet of Things. This is software in places where there didn't used to be software. And it's only growing. There's more and more of this stuff happening every day. And while the web drove a lot of the technological innovation in the last 20, 30 years, that was like one of the major platforms, this is going to become more and more of a thing, and more developers are going to be needed to develop this kind of software. And so, after that other developer sort of disappeared and I started working on this thing, at first I was really comfortable. I was happy. It was Elixir. I know Elixir. The code isn't all that different. It's pretty much the same. But then I learned that there's actually one huge difference that I was not expecting at all. And it's deployment. So when you're working on a web app, you're deploying your code to servers you have access to, and if you're lucky, you can deploy however much you want. You want to ship code 2, 3, 4, 5 times a day? You can. That's great. But when your code is running on someone else's hardware that you don't have access to, that you don't control, your ability to deploy is severely hindered. You don't get to push code whenever you want. Maybe you never get to deploy again. Maybe the device you're building doesn't even have an internet connection. And so you need to get it right the first time. And to me, as a software developer, that gives me chills. That's a nightmare for me, because I know I'm not going to get it right the first time. It's impossible. Or is it? There are some things that we can think of to help us, if not get it completely right, minimize some of the things that we do get wrong. Now, we all want our projects to be successful. And Agile tells us that shipping is the key to success. So, we don't know exactly what the axis is on this graph. It might be logarithmic, it might be, really small, but we think that there's some correlation between your ability to iterate on your product and product success, right? But when you can't ship, you can't iterate. And so we have to fall back on waterfall, which basically gives us this. Our success is tied to our ability to predict the future, which is hard. It is far harder than shipping and iterating quickly. Now, when I say predict the future, I'm not talking about like tell me who's going to win the Super Bowl this year or if it's going to rain 2 weeks from tomorrow. But what we're trying to do is we're trying to predict the ways in which our software might need to change after we've deployed it so that we can make those changes before we deploy it. And that's really hard. But there are 3 main ways, I think, that software typically changes as we're developing and after we've deployed and when we're doing our iterations. The first of which is a biggie, which is we've built the wrong thing. We've spent a lot of time putting together an MVP, and we put it out there, and our users get our hands on it, and it's not what they want. They don't need it. There's too many features. There are bad features. The user experience isn't very good. And this happens all the time. And normally, if you're doing a web-based project, you can pivot. Or you can just iterate quickly and sort of get yourself out there as you get more feedback and learn about how your users are interacting with your application. But with embedded applications, that's not so easy. And especially if you're actually manufacturing hardware for this, if you're doing like a full manufacturing run and you're getting like thousands of PCBs printed up in Shenzhen and shipped to wherever you're selling them, you can lose a lot of money that way. It can be very expensive and very bad if you build the wrong thing. But even if you built the right thing, there's still probably going to be some bugs, right? And normally, when there are bugs, we find them, we fix them, we deploy, our users are happy. But if you can't deploy, bugs can be bad. Bugs can have bad user experiences, they can make the product unfriendly to use, and that can really damage both the product and the reputation of the product. And then the third thing is a biggie. Now, some people think of security vulnerabilities as a bug, because clearly somebody did something that wasn't intended, but the big difference here is bugs give us a bad user experience. Security vulnerabilities can be dangerous. So the stakes are way higher, and so we need to care much more than I have found normally we do about security. But if you don't have users because you built the wrong thing, it doesn't matter as much. So I really think the most important thing that we start with is product design. How can we try and make sure that we are building the right thing? Because this is one of the most expensive mistakes you can make. Does anybody remember this thing? This is almost too crazy to believe, but someone thought, I know what everybody needs. It's a $400 internet-connected machine that squeezes juice from a bag into a glass. And I'm going to spend millions of dollars making these and marketing them, and everyone will love it. And then someone else said, yes, that's a great idea. Here's millions of dollars to make and market your thing. And clearly, it wasn't a great idea. The company is gone. It became sort of a joke. But to help avoid this, I think there are 2 great things that we can do. First is an acronym, something called the KISS rule. It's something I heard a lot growing up playing sports in America as a kid, as my coach is telling me to keep it simple, stupid, because I was frequently trying to make something very simple, much more complicated than it needed to be. But this aligns pretty well with some other stuff that we already know in software, like the Unix philosophy of trying to make a tool that's very narrowly focused, does one thing, and does it really well. Because if that's what you're doing, it's really hard to get it wrong. It's hard to build the wrong thing if your scope is really small. If you go to just about any factory or warehouse anywhere in the world, you're going to see a lot of machines like this. Maybe it has like one moving pneumatic thing and a couple sensors, and all it does is stamp labels on boxes over and over. It's pretty hard to get that wrong. You can pretty well understand what you need to do there, and it's not very likely, because it's so simple, that you're going to build the wrong thing. So if you can keep your product small, do so. It's going to reduce the risk of building the wrong thing. But we're not always so lucky. We don't always get to build little pneumatic arms that stamp labels on boxes. So if we have a bigger thing and we want to try and reduce that risk, there's a thing out there called a design sprint. Now, this is something that came out of Google Ventures a few years back, and what it does basically is it helps to reduce the risk of your application by doing essentially a breadth-first search of the problem space, trying to do a lot of iteration and a lot of knowledge gathering and trying to rule out a lot of the bad ideas before you get too far into the production cycle. This graphic I took from a company called Thoughtbot, which is an American-based consultancy, but I think they also have an office in London still. And I think it illustrates what a design sprint is very well. A design sprint consists of 5 phases. Each one typically takes a single day. It can be done differently, but it's normally the way it's done is over 5 days. And what you really need to do this well is a good facilitator, somebody that knows how to run these, because they're very constrained by time, because we set these time constraints out to begin with. And what we start with is, the first phase is understanding. We are trying to understand as much about our market or our customer or the problem that we're trying to solve as possible. We talk to experts, we talk to customers, we look at research. We do as much as we can to try and get all of the information we might need to help design a really great solution to our problem. And once we have that information, we move on to the second phase, which is the diverge phase, where everybody involved in the process just tries to put as many different solutions out there as possible to this problem. It doesn't matter how simple or how complicated, how ridiculous and like seemingly impossible or how likely. You're just going for breadth. You're going for as wide a variety as possible. And once you have all of those options, you move on to phase 3, where you take those options and try and pick one. You converge on a single path forward that you think, after exploring all of these ideas and looking at all of the research we've done, we feel confident that this is going to be a likely path that will solve our problem for our users. And so after we've converged on that one, we need to build a prototype. Now, you might be saying, how much of a prototype can you build in one day? Clearly not much, but you can do stuff like, taking a little cardboard box and having pieces of paper where people pretend to push buttons, and then you put a new piece of paper on there, and you're actually going to get a lot of value out of that. You can figure out a lot about how a user might interact with the user interface without actually building a user interface. You can figure out a lot just with clickable mock-ups. There are a lot of tools that do those sorts of things now, and you can still get a lot of great information that way. So after you have your prototype, you need to test it. Now, the best way you can do this is to actually get real users, bring them to your space. If you have a space, you should hopefully have a space for this, and watch them use the prototype that you've made. What this does is it gives you very high bandwidth and high accuracy feedback on an application before you've even built it. It helps you make sure that you're going in the right direction, so that when you even start off, you're already several iterations ahead of where you had been had you not done this process. And it only takes 5 days. It's not that bad. It's not that bad of a trade-off from the pure agile method of just get something, anything out there, and then iterate. Doing a little bit of work beforehand is, I think, a really reasonable trade-off. But speaking about testing, I love testing. It's one of the things that I like to do when I'm working for a client. And typically, when I would test, I was operating under the mindset that it's impossible to catch all of the bugs, so we'll do our best. We will test for what bugs we can find, but we shouldn't spend too much time trying to exhaustively find all of the bugs before we ship. It's impossible to do, so don't even bother. But the thing is, that sort of move fast and break things mentality doesn't work in embedded systems because, again, if you ship a bug that you can't fix, there are problems there. And there are bigger problems sometimes than just bad user interfaces. There's software in a lot of places right now where if you ship a bug, the trade-off can be terrible. I mean, it can have catastrophic effects. So, luckily, there are some ways for us to sort of find what we didn't think about. It's hard to imagine the unknown unknowns. But some very smart people a while back at a Swedish university called Chalmers wrote this paper and invented this tool called QuickCheck. And this was originally written for Haskell programs, and it pioneered what is now commonly known as property-based testing or property testing. And property testing uses randomly generated inputs to help us sort of find all of the things in the problem space that we didn't think of. That is so valuable. It is so valuable, especially when the trade-off of shipping a bug is really high, when it can be a really, really bad thing to ship a bug. People can get hurt. And they're not that hard to write. So, this is an example of a property test. This is in Elixir. And what we have going on here is we're trying to define a property of a thing, in this case of addition, that the sum of any 2 positive integers will always be larger than either of those 2 integers. And it's really easy to come up with these properties for stuff like math, but it's also not too hard to come up with properties for your applications. Things like my application should never error. I should never return a 500. I should never make a user turn something off and back on again to make it work. These are properties that we can come up with, and then you can also come up with more strict or specific properties that you need. But the real power of this is in those two functions there, where what we're doing is we're just randomly generating positive integers. And we're going to let this run for as long as we can figure it to. We can run it for 100 times or 1,000,000 times, for 2 minutes or 20 minutes. We can let it run for an hour if we want, and just really exhaustively cover the entire problem space to try and find anything that we didn't think about. And then we know that the bug exists. Finding the bug is the hardest part. This is a great book that I recommend to people interested in property-based testing, and I especially love the subtitle, Find Bugs Before Your Users Do. That's what we get with property-based testing. The bugs are going to be there, they're going to happen, but it's so much better if we can find them and not our users. And Fred is a wonderful author. I think you'll be able to understand this even if you're not an Elixir or Erlang developer, even though the examples are in Elixir and Erlang. So now I have a question for you all. Who all here has some sort of application with maybe some monitoring or observability capabilities set in so that you can keep track of your application, you know what's going on there? Right, a fair amount of us these days. Now, of those people, who have you tested in production? Right, so I have some news for everybody that didn't raise their hand to both. You're testing in production. Whether you like it or not, whether you know it or not, you are. Because think about it, if you were sure that your software didn't have bugs, why do you have a bug tracker? And if you were sure that no matter the input, your software was going to respond in a certain amount of time or not exceed a certain amount of memory, then why are we monitoring memory and CPU usage or latency for a web application? This picture here comes from Facebook, and this is one of many racks of phones that they have at Facebook. And what they're doing is they have all of the different kinds of phones that are for sale, and they have all of the different kinds of operating systems that can go on those phones. And they're taking their app and they're going through a script of using the app in as many different ways as they can find. And what we don't see in this is that there are little cameras pointing down on each phone. And so what happens is that if the software runs into a bug, they have a video of the recreation steps for that bug. And this is testing in production, because these are the same phones that their users have, same operating systems, same versions of the app. It's just, in this case, they own production. And this is great, and if you're doing embedded systems, you need to do this. You need to be trying out your software on the actual hardware it's going to run on. This is even more so if you're dealing with very low-level things where different chipsets or different assembly languages will make a difference. You really need to test those thoroughly, manually, somehow, automated in some way if you can. But even manual QA is still going to give you a lot of value here. So I really recommend looking at embracing testing in production, even if you have to own production. But even after all of that testing, bugs are going to get through. It's part of life. It's going to happen. And so one day we're going to get a call from someone using one of our devices, and they're going to say, help, our thing isn't working. And you're going to say, okay, well, what's not working about it? And they're going to go, I don't know, it's just not working. And then they're going to say, well, what did you do to make it not work? And they're going to say, I don't know, I'm just trying to do my job. Like, I work in customer service, and I have this device that my boss gave me to do my job, and it's not working, and I don't know what to do, and you need to fix it. And we can say, yeah, well, you know what, you didn't give us a very good bug report, so I'm not going to be able to fix that. But that's not their job. Their job's customer service. Our job is making the thing work so that they can do their job. And so, normally in this case, we look at the logs, right? Hopefully there's something in the logs that tells us what happened, was this series of events, and they got the device into this state, and then that's why it froze, or that's why this weird thing happened. But sometimes, if we look at the logs and there's nothing there, we have to add more logging. And that requires shipping. And so we see where the problem is here. Well, if you are lucky enough, like me, to work on a language on the Beam, which is the virtual machine that Elixir and Erlang run on, this is a screenshot of something called the Observer. which allows you to connect to a live running application without turning it off, no rebooting, no changing the application state, no interrupting the application's evaluation, nothing. You can just connect to the application and get all the information you could possibly need. You can add more logging without changing code. You can see the state of all of the processes in your application. You can see anything that you could possibly need to diagnose the bug that's there. You can even turn on some tracing to get a specific series of events, if it's a series of events that creates a bug. This is a superpower for debugging, and it's especially valuable if you're in a situation where you cannot deploy additional logging as frequently as you might want. But if you are not so lucky and you have to use a language other than Elixir or Erlang or something on the Beam, you're going to want to have some sort of debug mode. This will hopefully just print out everything that you can possibly think of. And yeah, you don't want to run production that way because there is a cost to all of that logging, but this is better than having to try and deploy again. Having some way that a customer can restart the application in debug mode, which turns on all this logging, or some way that you can have a customer press some set of keys or something, do something to capture all of the state of the world, it's a good thing to have. So think about this if you're ever in those sorts of situations. Now, there's a little-known fact about IoT, and it's that the S in IoT stands for security. I know, there's no S. It's a terrible joke, but IoT is not a very secure world right now. Embedded applications are not nearly as secure as they should be, but it is so vitally important. I really, really hope that no one in this room has seen this screen before, or if you have, that it wasn't on one of your computers. This is what you see if your computer is unlucky enough to be infected with the WannaCry malware, which made the rounds in a big way a few years ago, but is unfortunately still a problem today. Now, the funny thing about this, when it was originally released, yes, it was using a zero-day exploit, which no one knew about, and there was no patch available for, so there was nothing that we as developers could really have done to stop it. But a patch for that vulnerability was released by Microsoft on March 14th, 2017. And yet, several months after that patch was released, that same vulnerability was used for a separate variant of this malware that caused hundreds of millions of euros of damage in Ukraine. It brought the country to its knees for a short amount of time. It is still a major problem today, even though a patch has been available for years. The unfortunate thing is users don't really update their systems all that often. Because again, these users may not be technology people. They might just be someone whose job it is to sit at this computer and use this thing to do their job. If they see a little pop-up that says, would you like to restart your computer and wait an hour for this to update, they're probably going to say no. So we need to do what we can to try and avoid situations like this. And unfortunately, there's not a lot that we can easily control, but one of the things we can control is the choice of programming language that we use. So this is the criteria for the Core Infrastructure Initiative. This is a thing that was started after the Heartbleed vulnerability was found in OpenSSL several years ago, and the collective programming community just realized, oh my God, this incredibly important piece of infrastructure is maintained by 2 unpaid volunteers. This is a problem. And so they put a little money aside to try and fix it, and now if you have a piece of software that is used widely and is deemed to be core infrastructure, something that is very important, you can apply for grants to the foundation. And in that application process, they ask you to calculate a score for your project to see how far up the list it should be on the grants. And as we can see here, one of the ways that they judge somebody in need of help is if the main language is C or C++. These are inherently insecure languages. It is very easy to write a safe program in C or C++. So please, if you don't have to use C or C++, don't. It's going to make a more secure application if you don't. If you need something at that level, Rust is there now. It is safer. It's not perfect by any means. I'm sure there will be days when bugs are found in Rust code, but it's going to be better than C or C++. If you can use a higher level language, please do. That's going to be great. You're, again, removing entire classes of vulnerabilities from the possibility of your device. Now, I love open source software. I contribute to it a lot. I think it's important. But I do think it's funny that this is the one place that we trust strangers on the internet. It seems like everywhere else in the world, we've sort of agreed that strangers on the internet are bad and we shouldn't trust them. But when it comes to code that gets run on people's computers, we're like, oh no, they're probably fine. This is funny. And I do think that you should use open source software in your applications. But I also think it is reasonable and it is smart to limit the software that you use that is not maintained by someone on your team. It's just the cost is too high. Security vulnerabilities are big deals, and they are becoming more and more common. So please don't assume that code written by strangers on the internet is okay. Audit the code. At least look at the code. See if it's just getting something from Pastebin and evaling random strings. Like, that's probably a bad idea. You might not want to use that package. There are a lot of other ways that you can try and mitigate the risk coming from open source dependencies, but please just think about it a little more. There are certain languages where using thousands of dependencies is a common practice. This might not be such a good fit for embedded applications. You might want to pick a language where you get more in the standard library or where more people are writing their own code. And another point is you're going to want to get an expert, because probably no one on your team is an expert in security. You probably don't have one of those people on your team. There are not many of them, and that means that they're a little expensive. They might be expensive, but you're gonna pay one way or another. You're either gonna pay an expert to harden your system and try and find all of the bugs and all of the holes before they get shipped, or you're gonna pay when someone else finds it and hacks your system, and you either have to pay a lot in fines, or you pay a lot by the fact that all of your users have left because you have an insecure system. Now, what I've been talking about has been pretty much about embedded development, but the thing is, a lot of this is still applicable to the web. I still do most of my work on the web, and I've taken a lot of these things back into my work in web development. So for example, starting small is still great for web applications. You still want to start small because it helps you get out faster and you can iterate faster. You want a nice small MVP. There's a lot of advantages to that. You also, I think design sprints are lovely for the web. If you have a large new feature or you're redesigning an application, you're changing something about the user experience, design sprints can get you a lot of value for a short amount of time. Also, I genuinely think that property testing is a tool that should be in every developer's toolbox these days. The additional cost of writing that test is very low, and the value is enormous. You know, you can get millions of tests for the cost of 2. That's a pretty good savings in my book. Browser testing is something that we can now automate very well. There are great services out there if you're building a web application that's actually run in the browser and not just an API. There are great tools that will run your application on every version of every browser, and they'll do screenshots if something goes wrong, and you can automate all that stuff. And it's really valuable because you know that your users are going to be using your application in dozens of different browsers. And testing them manually in all of them isn't so fun. Also, I genuinely think Elixir is a great language, not just for embedded applications, but also for the web. There are world-class tools and libraries, and the language itself, I think, is one of the great ones. So if you haven't looked at it before, really, it's a great one to look at. And also, please, care about security. I can't tell you how many times I've been on teams where no one even thinks to care about security. It's just not a thing that people think about. So even just starting as simple as someone saying, hey, when's the last time we audited our dependencies? Or when's the last time we looked to see if there were any open CVEs for any of the dependencies we use? Thinking about it is a great step in the right direction. Now, do I need to do any of this? No, you don't. But that's the great thing about Agile. We can experiment, and we can try these things, and we can see what works for us and for our team, and we can see what adds value and what doesn't. There's a lot of value in this experimentation, and I hope that when you all go back to your jobs on Monday or whenever you're going back, that maybe something here is something you might want to experiment with and see if it's a great addition to your team to help make your products better for your users today. So, that's it for me. My name's Devin. If you want to talk to me about embedded software or Elixir or consulting or anything, I'm going to be around, and I'd love to talk to people. So thanks very much.